Welcome everyone to the virtual open house for Trent University. We're excited to welcome you to the Physics and Astronomy information session. I'm Kathleen. I will be moderating this session, and with me today I have Professor David Patton, I have Professor Balaji Subramanian, and I have a third-year student who is a mathematical physics major, Raven. Welcome, Raven. So thank you to our panel for joining us today and sharing your wisdom about the program, excuse me, with our prospective students. Excuse me. So we're excited for the path you have ahead of you and look forward to sharing all of the reasons why Trent has been ranked the #1 undergraduate university in Ontario for 11 consecutive years. During this session, you can ask questions in the chat at any time or at the end. So if a question pops up in your mind, just throw it in the chat. We will have time for some Q&A after we go through some panel questions. This presentation is offered with closed captioning. So I'm just gonna pop that on right now. There we are. And on our events page, you will see a few live chats happening today. So you can drop into any of those chats that make sense to you and have your questions answered. There's also a ton of these information sessions happening. So with that, we will get on with our panel presentation. So welcome everyone. So my first question is for Professor Balaji. What are the types of courses that students can expect to take in their first year in the Physics and Astronomy program? And how does that change as students progress throughout?
Oh yeah, this is a very interesting thing that all the first year students must know. And I'm very happy to provide information on that. I would start by sharing the screen for that and make a presentation. So if somebody wants to take notes, they can take notes. Are you able to see the screen, guys? Okay. So basically, what are the types of courses students can expect to take in the first year? We have introductory physics, astronomy courses, and then upper year physics and astronomy courses. For the newcomers, it is very important for you to know more about the introductory physics courses. We have three streams of introductory physics courses. One is 1001 and 1002. This is offered in 2 terms, and another course is Physics 1000, Foundations of Physics. Then the third type is Physics for Life Science students. Okay. In addition to these introductory physics courses, we have introductory astronomy courses 1 and 2. That is also very popular in the campus. Okay. Now, let me take you through the details of each of these courses. Physics 1001 and 1002, 1001 and 1002 is the primary physics course, which is specifically designed for those students who wants to shape up their careers as scientists or engineers. So for this course, if you want to register for 1001 or 1002, it is strongly encouraged to have 4U physics and 4U calculus and vectors. Okay, in this physics 1001 and 1002, you will be learning about university level mechanics. At the same time, we will learn some introductory ideas on electricity and magnetism, and some properties of materials and how the sound waves behaves and all those things more in detail. Physics 1000 is targeted towards those students who want to know physics, but they may not have had necessary mathematical background. So this talks about foundations of physics, and this is also addressing some of the pertinent topics like mechanics, and in the mechanics, it talks about both kinematics as well as the dynamics, both in 1 dimension and 2 dimensions. But physics for life sciences student is also another popular course in the campus. Here, we will be exploring some of the basic biophysical ideas, and then we will discuss the physical concepts behind those biophysical phenomena. Okay, so this would talk about the buoyancy, mass transport, temperature, all those very interesting things will be discussed here. Why this COVID virus would travel 2 meters, all those things would be addressed in this course, okay, just for fun. Then we have introductory astronomy physics courses, that is the 1510H and 1520H. This is more like a general sky phenomena, and it talks about the history of astronomy, telescopes, and detectors. Professor Patton is here with us, and he would be able to say a few more words about these two courses. Professor Patton, please.
Sure. So I'll just say briefly, our introductory astronomy courses are actually open to any student at Trent. You don't need a particular background in science or math or anything like that. So we get science and non-science students that take the course, and we cover everything in astronomy from, you know, the moon and the stars you see in the sky to the universe as a whole and the Big Bang and black holes and all of that stuff. And there's also an opportunity to look through a telescope and see things like the rings of Saturn and moons orbiting Jupiter. Back to you, Balaji.
Yeah, thanks, Dave. And that's a very interesting and exciting information. Actually, the degree programs that we have here basically targets towards BSc physics degree, chemical physics, mathematical physics, and computation and physics. So here in the chemical physics program, we have some courses which are having significance towards the chemistry. Mathematical physics programs has more interesting and important advanced math courses. Computational physics course, computation and physics degree program gives us an opportunity, gives the students us an opportunity to blend some of the computing aspects with their physics degree program. However, all these students who take, all the students who take all these four, who follow any of these four programs would do these four fundamental courses: classical mechanics, electricity and magnetism, thermal and statistical physics, quantum mechanics, because these four courses form the foundations of upper year physics program, and all the students who register for these degree programs are expected to do all these four courses. In addition to this, we have lab and computing skills is in great demand for these four courses. So you will get to know very important aspects of computation as well as hands-on experience with the labs. So this is the pathway towards the degree program.
That's great. Thank you so much for sharing. So just
again, I will stop sharing the screen. Yeah.
Sure. Yeah. Okay. Well, thank you so much for that. I think that's great information for those folks who are interested in physics and kind of want a snapshot of what they're going to get started with. And with a lot of programs at Trent, I find, yeah, in sort of that first year, you're going to learn a lot about everything in the field, sort of little bits here, and then you can start to kind of narrow your focus into your areas of interest as you move through the program. And you can also be involved in research as well. So my next question is for Professor Patton. What do some of our graduates do once they're finished with their degree at Trent in physics?
Okay, that's a great question, and it's not a simple answer as it is in some other programs. Students who come through any of our degree programs, whether it's the standard physics degree or mathematical physics or chemical physics or computing and physics, they go on to really quite a variety of different kinds of careers. Quite a number of our students go on to actually teach in high school, and they'll teach physics or mathematics or something of that nature. So we have quite a lot of students do that. We have a fair number of students who will go on to graduate studies in physics or astronomy or a related field. And so we have students who have gone on from Trent to do astrophysics, medical physics, optics, condensed matter physics, quantum computing, all kinds of interesting things that follow on from what they've learned at Trent. And some of them will go on and just do a master's, some will do a PhD and have a whole career in academics. There's a whole range of outcomes there. And then kind of the third category, I would say, is everything else, which is actually quite a variety there as well. We will have students that go and work in industry, in some cases in fields that are closely related to their physics background. So we've had students who've gone on and worked, for example, in a nuclear power plant, or gone to work for a research lab, gone to do medical imaging work. But then we have some students who go and work in the finance industry or in the computing or tech industry. And you might think, well, what's the connection with physics there? But in fact, with physics, we really teach you a lot about how to learn and how to think analytically and how to solve problems. And that really translates to a whole range of different fields. And so we have students who have graduated from our program who are doing all kinds of interesting things. And so it's actually hard to predict in advance when you start a physics degree at Trent, what you're going to end up doing. But I will say that our students are very successful at finding work and finding careers with the background that they get in our program.
Thank you so much. Great answer, great information for those who want to know, what do I do with my degree? Lots. You can do lots, lots of things with your degree. So my next question, for whomever would like to take it, what exciting research is going on in the physics and astronomy department at Trent, and can students participate in faculty research?
I'm happy to answer that just because Balaji's done lots of talking already, so but he can chip in as well. We as faculty in the department are doing lots of research in a range of different areas. I myself do research in astrophysics, but there are others who do sort of condensed matter theoretical research. There are optics labs. There are all kinds of interesting experimental studies that are underway. And there are lots of opportunities for students to participate in that. I'll give you a good example of that, which is Raven, who's on the call here, is going to be working with me this summer on a astrophysics research project. And so that's a type of opportunity to come and work in a summer paid position with one of your professors to work on their research. Another possibility is, in terms of research opportunities, we have a fourth-year project course, which means you can spend essentially the equivalent of a full year course working on a research project supervised by a professor in an area of research that you're interested in. And that counts sort of in place of 2 regular one-term courses that you would take in other areas. And that's a great opportunity to get some experience with doing research, seeing if you really enjoy research. And that's particularly helpful for students who want to build their skill set and may want to go on to graduate studies or to some sort of position or job that needs some sort of demonstrable evidence of sort of working in the field and carrying out, for example, working in a lab and learning how to use lab equipment, that type of thing. So those are probably the two main avenues for students to get involved, is either in the summertime or in fourth year to work with our faculty. Balaji, do you want to add anything to that?
You have pretty much covered all the important aspects, Dave. If there are any students, any questions from the students, I will be able to take it. No problem. Yeah.
Thank you so much. And Raven, I don't want to put you on the spot, but I might. What made you want to engage in some undergraduate research?
Well, last summer I was talking to it was before the summer, I was talking to one of the other physics professors, Professor Atkinson, and he suggested that I apply for one of the biochemistry scholarship. It's an NSERC USRA scholarship, which pays for 3/4 of the summer payment, and the professor covers the other quarter. So I applied to work with someone in the biochemistry department, and I got the position. It was a lot of fun, but it wasn't quite clicking with my particular interests. So this year I asked early on if Professor Patton would be willing to do one with me, and then I went through the application process and ended up getting the scholarship again, which was really great. I actually only got the acceptance yesterday, so I'm still riding that high. And yeah, I really enjoy staying in Peterborough on campus during the summer. It was great. I saw Balaji like a couple times a week over the summer because I would go by his room where he was working on my way to go work on Trent's NMR machine, the giant magnet they have in the bottom of the science complex. And it was really fun. You get to interact with the professors in a really different way during the summer.
Thank you so much for sharing. Yeah, and it's funny, that's something that as a Trent alumni, I probably took for granted that not all undergraduates get the opportunity to do that type of research, and we're really lucky at Trent to be able to engage in those types of experiences and have something that really aligns with your interests. And so many faculty members are excited to include students in that research, which I think is awesome. So congratulations! I didn't realize that you heard yesterday. That's so exciting.
Yeah. Oh, in addition to the information that are shared by Dave and Raven, I just wanted to say that there are other research opportunities also for the students in the campus. For example, I hire a student who worked with me in the summer throughout the year in a part-time basis. That is also possible for those students who really want to wet their hands in the labs. So there are multiple opportunities. So if there is a drive, there is a way. Okay, so.
Thank you so much. Yeah, that kind of ties into my sort of final question, which is what experiential learning exists within physics and astronomy? So outside of research, as you mentioned, students can get paid positions or do some other things. Are there any other experiential components you'd like to talk about?
Yeah. Dave, I'll take this question.
Sure.
Here, when we talk about the experiential learning, we have a very unique second year physics, computation-based physics course, which develops the necessary computational skills, and that computational skills will be carried out throughout the upper year physics courses, for example, third year and fourth year physics courses. So a student who graduates with a physics degree would have reasonably strong computational skills in Python, for example. And then we have two electronics degree courses, electronics courses. And in those two courses, we have the lab hours, extended lab hours compared to the other schools, I would say. Those extended lab hours let the students to build the electronic circuits, analyze their functionalities, and the second electronics course, the students would be able to apply them in any particular system and to make it functional. Okay, so this is a very interesting experiential program. And other than this, we have as a taste of experiential learning, the students who do this introductory quantum physics course would do this charge to mass ratio, finding the charge to mass ratio of the electron and finding the speed of the light. All those kind of experiments are possible. In addition to this, we have material synthesis labs where we have used this thin film preparation methods, then 3D printers, etc. we can work with. And also, being a part of a physics department, you can participate in learning some of the analytical instruments, how to operate the analytical instruments such as spectrophotometer, infrared spectrometer, all those things. So if you want to have a career on chemical physics based on background, those things would come into great help. So these are some of the experiential learning that you can experience if you take a physics program. Yeah, that's what I wanted to say. And Dave, if you have anything to add, please go ahead.
Just the one thing I would add is there are some opportunities for students to be involved in teaching in terms of teaching assistant positions, helping out in physics labs. I supervise a student who works with our telescopes when we have observing sessions with our astronomy students. So he helps to set up the telescopes and run the telescopes. And so some of those students will go on to Teachers College, and they have got some experience while they're at Trent, getting started in their career in that way. So that's another useful thing.
Yeah, actually, you mentioned a very interesting and important aspect today, I think, because now in the high schools, there is a dearth of physics teachers. Like we don't have much physics teachers to teach high school physics. So that would be a new opportunity. So.
Yes, so true. Physics is in very high demand, as is math. So Raven, if you switch up your career choices, I think you'll be really good to go there. So I do have a couple questions for Raven, just related to student experience. So would you mind telling us what you love most about your program?
Yeah, for sure. When I was deciding what program to take at Trent, I was having a really hard time deciding between physics and math especially, but also chemistry to a certain extent. Mathematical physics struck a really nice balance for that. I think the main drawback of it is that if you take more than a single course elective, you do not have room for a minor, which I found out at the end of my first year after taking 2 electives. But that's okay, because now I have time to dabble in a few other things that I find interesting. So I've been taking some astronomy courses, I've been taking some geology courses, and it's been really nice because I get a bit more emphasis on mathematical proofs than a standard physics degree. But I also have a little bit more upper year flexibility. So I lose some of the first 2 years flexibility. I had 2 electives between my first 2 years, but from here on out, all my physics friends are jealous because I have so much more choosing, at least on the physics side of things from here on out, which is really great.
That is great. Thank you for sharing. And my second question for you is, what advice do you have for students planning to study physics at Trent?
Oh boy, how much time do I have for this one? Well, there's quite a few things. I think my main one, which I've been saying, I'm an academic assistant for a few courses, and every time people stay behind to ask questions, I try and drive this point home. Go to office hours. Even if you don't think you really need it that week, if you have time, go to the office hour anyway. If you don't have time, go to half the office hour. Like, you get to know your profs, and when your profs know you, they know more about your situation. They're more willing to work with you if they know that you're trying. I've been going to Balaji's office hours since the start of the semester. I've been one of the only students to do so, and now I've started dragging my friends with me every Tuesday and Thursday. And it's been amazing. I'm doing a lot better in the course now. Other advice would be to join some clubs, and especially the math club SUMS, the physics club TUFS, and if you like that sort of thing, the gaming club Gatto. All 3 of those are really solid choices. There's other clubs as well, but those are my personal favorites. And study outside of your room, especially if you're living on campus. I made this mistake in my first year. Every day I would sit on my bed, I would have a Discord call open with my boyfriend who lived 3 hours away, and I would study pretty much 100% of the time that I wasn't sleeping or in class. And it sucked. It was awful. This year I've been studying in the math resource room, which is in Nwang, the yellow building. I've been studying in the physics layer, which is on the 3rd floor of the science complex, and it's pretty close to Balaji and Patton's offices as well. Those are both solid options. The library has private study rooms. Bottom of Zosky's pretty chill place. Sorry, that's Nwang as well, the yellow building. It used to be called Zosky. And the other main point is to make sure to take time for your physical and mental health, as well as keeping on top of academics. You should put your physical and mental health first. there's great opportunities to go for walks on the Drumlin. It's like the hiking trail behind Lady Eaton College. The gym is also nice. It's great to go in a group if you're not comfortable going alone. And then there's also some things that help more with mental health, like there's Rebound, which I took part in my first year. They help you organize your time better, and they can direct you to further mental health resources if you need it. I got really lucky. The girl I was matched up with actually took me downtown to get my flu shot because I wasn't comfortable going downtown alone in my first year. And there's also therapy that is included through your degree at Trent. And if you ever feel you need it, don't back away from reaching out to that opportunity. It is much easier to get on the list during the summer. If you're finding you're having difficulty during the semester, try and sign up again during the summer. It should go through much more quickly at that time. But yeah, those are all things that have helped me through my time at Trent, because, you know, I've had a lot of really good times, but there's also times, especially close to midterms and exams, where things get overwhelming, especially if you haven't really met very many people in your program yet, and it can be hard to just kind of break out of your bubble, especially if you're more shy or introverted and stuff.
Thank you so much, Raven. That is all really, really great advice. Yeah, and definitely connecting with profs. A lot of the time, as you know, especially in first year, it's hard to really even adjust to that idea of like what, you know, like why, you know, I haven't done anything wrong. I don't need to meet with my prof. But yeah, I can remember profs like just loaning me books or materials for either a paper in that class or even another class, just because, like you said, they get to know you, they get to know your interests, and can really help you throughout your program to make sure you're getting the most out of it. So I think that's great. And thank you for mentioning all the resources on campus. That's also very valuable. So yeah, so for those who are tuning into our session, if you do have questions, just a reminder, you can pop it in the chat. You can also raise your hand and we can do it that way if you're comfortable with talking. Either or. We only have a couple minutes left. So if I don't see any questions, final call to our panel. Is there any other little bits of information you think folks would benefit from knowing if they're interested in physics at Trent?
One thing which I wanted to mention is the advantage of a small campus. We have very, that is a major strength of a small university. The students get to know professors get to know the students more well. I know all the students by their first name and second name in my class. That has been the case for those years that I am at Trent. Okay, so I mean, even I had the experience of remembering all the 60 names in the class without any problem. So this kind of one-to-one interaction makes that would make you feel very important in the and then that would drive you to learn more. So that is a very major advantage of being at a small university like Trent.
Yeah, I would just add to that, we're a friendly department, lots of great professors, and we always have students who are happy to interact with the physics club or what have you. So it's a nice place to be. We always enjoy the students, and students generally have a good experience at Trent.
Thank you so much for sharing. So again, for those who are tuning in, I threw a couple links in the chat just if you wanted to check those out. We do have virtual tours that you can check out, but also we do have in-person tours. So if you did want to come to campus, check things out, see it for yourself, see if you can picture yourself here. Always a great idea. We have those Monday to Saturday. So yeah, so it looks like we're at the end of our presentation. Thanks again to our panel for joining us and sharing their wisdom with us about the program. This session has been recorded and will be posted on the Open House webpage, usually early next week. If you wish to review it, or if you want to view any of the other sessions, I'd like to just say thank you again to all of those who joined us today. And yeah, if you have any questions, there's lots of chats throughout the day, admissions, student services, things like that. So pop into any of those that suit your needs, and hopefully we'll see you on campus in the future.